じゃあ、ジムコプリエンさんです。コープさんです。よろしくお願いします。あ、音が入ってないかも。ごめんなさい。Sorry. The sound is not coming, I think.
Mic. We need a mic. Turn it on. Does the red light? It is okay now. Okay.
Okay, coming.
Thank everyone. Starting with Yasunobu-san, who invited me here. Kiro-san, who's been hosting me royally with sushi and whiskey and and other things, and everyone else. I follow some great talks. I did not know that Kyun-san was going to be here. In fact, I think I will be saying some things in my talk that reinforce some of the things that you said in your talk. I'm very much looking forward to a hug afterwards and seeing you again. So how many of you are programmers? You write code. So how much code have you thrown away today? How much? 100 lines? 1,000 lines? 10,000 lines? So part of this talk is presented a little bit provocatively in asking this question again and again, but it helps emphasize a deep principle that I think is very important. And in fact, Agile got it all wrong. Now, what's interesting is that Scrum got it right. And everyone kind of equates these two and thinks that Scrum and Agile are the same, and they're very different. And Lean is yet something else, which is completely different. Okay, so Scrum is most like the Toyota production system. Those two are very close. And then there's Agile, which is something else. And there's Lean, which is something else. And when I go into a Scrum shop, I find most people doing Agile. And it's extremely counterproductive. It's wrong. It creates local optima. It creates waste. And it's naive. And those of you who have taken a Scrum course from me, how many have I taught in Japan? 40, 50? I mean, many Scrum courses I have taught here in the past 15 years. I emphasize this. But finally, I kind of have a theory, or I have a story to tell about why this is true. And I want to bring that story to you here today. And hope we can have some good arguments over sake later. So yeah, Agile got it all wrong. And what Agile got wrong is this simplistic notion of inspect and adapt. Inspect and adapt. Inspect and adapt. And we go one step at a time. And it's like a horse that has blinders on. My wife and I have 3 horses. And if you ride them with a carriage, they have a blinder so they are not distracted by people or other horses on the street. You want them to go straight ahead. And Agile developers call this trunk development. I'm developing along the trunk. Because if I branch, then it's very costly to merge things back together. So branching is not a problem. Why did my Zoom connection drop? Why does this always happen at conferences? We've been working on this technology for 40 years and we still don't have it right. All right, and try again. So why are we here? Why did we get this all wrong? And I think it was because in the beginning, when the waterfall people were looking at what they were doing wrong, they were inspired a lot by some work called the spiral model. So spiral was kind of one of the first broadly published models from Barry Bain that broke out of the usual assumptions about waterfall. But everyone knew waterfall. Really? Are there feedback loops in waterfall? Can I go back from testing to analysis? How do you know? Where is the waterfall spec that says you cannot? You see, waterfall doesn't exist. It's a myth. It's a word that everyone uses, and they think they know what they're talking about. The closest that came to waterfall was a paper by Winston Royce, and that's where a lot of the ideas came from. And he has feedback loops all over the place. But the industry and the managers wanted something simple and something they could control and measure. So waterfall became the stovepiped collection of tasks. And then when people saw Barry Bain's spiral, they said, oh, this is just waterfall going around in circles really fast. And so I went to Wikipedia and looked up spiral. And we're going to define artifacts concurrently. Sequentially defining the key artifacts increases the possibility of a developer that meets win conditions. But this invariant excludes hazardous spiral lookalike processes that use a sequence of incremental waterfall passings in settings where the underlying assumptions of the model do not apply. And in Agile, they don't apply because in a chaotic world, when I'm dealing with complexity, all the rules are broken. And in fact, what Bain said about his model is that these things can be in parallel or in any order, and it's truly chaotic. But the managers said, I want this to be in a nice circle. I can make nice view graphs out of it and nice PMI charts. And Agile was born. We've been following this ever since. Okay? So, how much code have you thrown away today? You see, waterfall keeps moving forward and adding code. Oh yeah, you change a little bit, right? But you want to keep that code. My gosh, I just spent a whole week writing that code. I'm not going to throw it away. And I have been through code inspection and code review and unit test and writing the manual page for it and documentation and all of this other bullshit. So of course I'm not going to throw the code away, even though it might be wrong. I haven't tested the system yet. So we get very attached to this code. I mean, my talk today is going to be about this. Now, I could talk about 6 or 7 things that are wrong with Agile with a straight face. And I thought I'd take this opportunity, as kind of an Agile talking head. I think I have a name in the Agile community and in the Scrum community. And I think it will take someone with credibility to get this message across. So I really want to shock you. And my goal is to get you to think. Are you paid to think? Are you paid to think? Are you paid to type? Right? And that's the big change here, is everyone is paid to type, and we're paid to think. So there's a lot of other things I could talk about. I mean, we talk about small steps lower risk, but small steps lower big progress. I mean, end users do not use the small increments. They use an entire use case. And that's what we should be focusing on. But we deliver these small pieces, and we think that the entire use case is the sum of the parts. But in the complex system, the whole is larger than the sum of the parts. This is called Gestalt theory. So incremental small steps don't work. The whole team creates synergy. Yeah, but it can also lead to groupthink and being blindsided. Trunk-based development means you always move forward. Well, in real life, you don't always move forward. Learning is sometimes, 2 steps forward and 1 step back. And so it means we're not going to, don't confuse me with these things off to the side. I need to move forward because my manager is tracking my lines of code, which is why you're all using Jira. And the first thing, if you do nothing else from this talk, throw away Jira when you get home. Small functional increments support rapid feedback, but large features are more than the sum of their parts. And we're user-focused with user stories. There are no user stories in Scrum. I never want to see a user story on the product backlog. What's on the product backlog is an enabling specification of a product increment, not a user story. Now, user stories are good for a conversation between the product owner and the end user in a drunken conversation at the bar. To try to understand end users' pain. But users don't know what they want. They know their pain. That's what they know. It's the product owner's job to innovate solutions, looking at multiple customers and trying to generalize across them and finding a solution that will create the highest value across the market. Not to go to each customer and individually deliver what they ask for. They don't ask for it anyhow. When's the last time one of your users wrote a user story? Or is it your product owner? Yeah, individuals and interactions. We're not very good at this. Okay? So there's a lot of things we do wrong, but I want to focus on this fact that we're doing trunk-based development. Now, there's kind of a yin and a yang here, or at least they're alternating layers, and it's a little bit confusing. And in fact, I don't have this perfectly sorted out yet. But let's just start, at least I want to start by defining trunk-based development. So we can view the development line as a tree. And trunk-based development means that I only go up the trunk, okay? I'm not going to be looking at anything off to the side, all right? So, I mean, I just don't look at them and everything gets folded back to the center. And so when I'm evaluating the next step, all the assumptions that I made about the current step are still valid. And this greatly reduces my ability to test other assumptions, right? I mean, I will delete a little bit. But, I keep asking, how many lines of code did you delete? And if you said, well, okay, I deleted all the code I wrote yesterday because I learned from this increment that I delivered the wrong thing. And now we will try something else. Now, if you do that, maybe you're okay. Does anyone ever do that? You completely wipe out your last day of work. You completely wipe out your last sprint. This is about learning. It's not about building a mountain of code. The #1 output of a Scrum sprint is learning. It's not code. This is how well, going all the way back to Nanaka Sensei, how he defines it, right? It's about organizational learning. And that's what drove a couple of folks named DeGrasse and Stahl, one's a man and one is a woman, to define Scrum for software in 1990. And then these other two guys came along and commercialized it in 1995. And they added a lot of things. Why? Because you needed a certification test for them if you wanted to build a Scrum Alliance and have certification. So we put in daily scrums and product backlogs and sprints and all kinds of things. I mean, not because I find them from Takeuchi-san and Nonaka-sensei, not because I find them in DeGrasse and Stahl, but hey, we need something that managers can be familiar with. They like, deadlines, targets, right? And so we have fixed length sprints. You won't find that in DeGrasse and Stahl. You won't find that in Nonaka, right? These are things that were added later. And, the certification people teach them. And I mean, trunk-based development, the alternative, branching, allows divergent development. But of course, it's painful to fold those branches back together. So a lot of these agile practices increase product cost, they introduce errors, and they create rework. Oh, rework, we all hate rework, right? This is what the lean people say, the Toyota production people say. How many people do refactoring? Oh, you've given rework a sexy name. So now it's a good thing. It's rework. Okay? So, now not in the beginning, it wasn't. In the beginning, rework was something local, but now rework basically means redesign. But we say it's a good thing. And again, I do it incrementally. I don't want to throw code away. I'm going to add code to fix what I have done. Now, all of this comes back to this model of development based on, I take a next step based on what happened in this single step of a single thread. And this has been popularized, particularly in Japan, by a great man in Japan called W. Edwards Deming. So Deming came up with the plan, do, check, act cycle. And then he later changed the word check, which just means, okay, we've done it, to inspect, which means, okay, we're really going to understand this. He said, there is no substitute for a system of profound knowledge. This really means inspect. So automated tests are a check. Interactive manual testing is inspecting. So except for your regression tests, the second thing you will get rid of when you go home are your automated tests. Toyota is getting rid of its automated robots that weld car bodies onto car frames, and they are now done by human engineers because robots don't learn. This is about learning. This is not about automated testing or automation. So there's a lot of things that we do, a lot of practices that go back to these naive assumptions. But okay, we have plan, do, inspect, act. And so that's the Deming Foundation. Deming's an old guy. We have the Spiral Foundation. Barry Bain, I think he passed away last year. I don't think he's around anymore. And if we kind of map these onto each other, this doesn't even go in the right order. If I follow Bain's spiral, I'm going to do plan, inspect, act, do. But Bain says, I really don't care what order you do these in. And many people are doing them in parallel with everyone doing all of these all the time. Many people doing all of these all the time. Does this sound familiar to anyone? Have you heard this anywhere? Or all at once development? There's a name for this. It's called Scrum. Scrum is not agile. Scrum is based on something called swarming, which is different than the step-by-step trunk development incremental changes. We'll talk more about the differences between these in a minute. But people confound these. They think they are the same thing, and they're not. So why doesn't this work? And the reason it doesn't work is complexity. Okay? I'm from Denmark. And in Denmark, we have a physicist named Niels Bohr. And Niels Bohr said, be careful about predicting things, particularly if they involve the future. And modern physics, I mean, time is symmetric. Time actually moves in 2 dimensions. There was actually some work published just 2 weeks ago, another experiment that has validated this, which means that if you're a project manager and you think you can predict the future, forget it. I mean, you'd have to violate the laws of physics to predict the future in a complex system. And we know that, right? So we use iterative development. Well, okay, this was wrong. We'll fix it up a little bit. The problem is, in fixing it up a little bit, you're not visiting your fundamental assumptions. And very often, I'm finding that teams' fundamental assumptions are wrong. They need to take 3 steps back. But there's this human model of cause and effect. I just implemented this, and now I have a bug. They don't understand that the seeds of that bug were 3 sprints ago. And they don't step back and look at the entire system. They try to say, what did I do just this sprint? And now I do a small increment. And you end up with a tar pit. You end up with local optimization. So we either add rework and, okay, this doesn't work. Let's throw away the last sprint and start over. Okay? I have a friend named Dave Thomas who does this. He's filthy rich, wonderful guy. And he starts up companies as a venture capitalist. And when he starts up a company, they first build a prototype of the product and throw it away. Then they build the product and throw it away. Then they build the deliverable, release 1, release 2, release 3, and throw it away. This isn't about typing. Do you think they have any problems with technical debt? If you're throwing away your entire code base every 3rd cycle, you don't have any technical debt. So this is one heck of a competitive approach to effective software development. It's really extreme, but you need to break out of this fear of throwing your code away, and we're afraid to throw our code away. Okay, so we save as much of our work as possible. I mean, Freud said that human beings like to hoard their feces. And that's what you're doing when you're saying, I'm not going to throw this sprint away. My gosh, look how much I spent in building all this code. I'm gonna hoard this code, like cavemen would hoard their feces. It's a very, very deep animal instinct in human beings and in primates. So, no, I mean, we're intelligent. And we know we make mistakes. Now, this may be, I think there's a big opportunity for this in Japan compared to in Europe. Japanese understand Hansei. Wow, we screwed up this sprint. Wow, this is great. So not the, we're going to beat the team kind of Hansei, but the kind of Hansei where we celebrate the fact that we messed up and clean up and start over. Whereas kind of the Puritan European ethic is more like, oh my gosh, I have sinned, and that's a thing against God, and oh my gosh, I might go to hell for having written this code, and so I'm not going to throw it away. And this goes very, very deep into not only culture, but into human behavior. So looking a little ahead at the solution, there is going to be rework. You are going to make mistakes. Be careful about predicting things, particularly if they involve the future. And we can do this in a costly way, or we can do this in a cheap way. And there's kind of two parts of development. One is analysis, and the other is design and implementation. And testing just cuts across everything. If I'm doing rework in development, that's waste. That's muda. Rework in analysis adds value. There's an analysis of this in a paper out of the Lean Institute in California by an author named Ballard called Negative Iteration. And he says, no, we're going to take this rework and move it into the analysis phase. So this isn't about inspect and adapt, inspect and adapt. We're going to do good analysis up front. Oh, what's that? That's waterfall, right? Well, the way people do waterfall got it wrong too. There are some learnings we can bring from the agile side. We're not going to go back to simple waterfall either. And I'm going to propose something called set-based design, which is kind of a hybrid between the two. And by the way, this is not well-worn practice. There's many companies using it. It's just that speakers at this conference don't talk about it. And speakers who come to this conference will tell you something, and then you're a speaker at the next conference. And over the past 20 years, we've spread this stupid inspect and adapt mantra, and it's killing us. It's time to wake up and roar into the insights of the 1980s and the 1990s. Okay? So just as a metaphor, let's say we're going to climb Fuji-san. And so, I mean, we do some planning. No one has ever climbed Fuji-san before, many, many years ago. And we're going to kind of plan a route from the top. We can see, you know, where the major valleys and cliffs are, at least down low. And so we set up some base camps in order to climb Fuji-san. Now, what we want to avoid is going up a path and then having to turn around and come back and try something else. That's rework, right? We want to avoid that. So it takes some planning. Now, we can't plan perfectly. And maybe there has to be some, you know, plan, do, inspect, act, or some kind of feedback in the moment. Okay, so we want to do this, but if I do this only incrementally, I have only local knowledge. So, okay, well, yesterday I came here. All right, well, that was easy. Now, ahead of me, I can go this way or this way. And I use yesterday's experience to judge where I should go today, you know, and looking at the mountain. It's all local optimization, just like refactoring is local change. Just like product backlog items are very small. They should be about a half day or 1 day of work. It's not a global view. It's a very restricted, local, myopic view. So we can climb Fuji-san that way and do things incrementally. How many of you make incremental changes to your user interface? Do you know that completely destroys the usability of the user interface? Users get productivity at your interface by habit formation. So they have muscle memory about where the buttons are. And if you start moving buttons around or adding screens, it destroys the user experience. Talk to any user experience person. Any user experience person here? No, of course not. They would not show up at an agile conference, would they? Because they deal with people. And we deal with processes and tools over individuals and interactions. See, you say the words, but it's a lie. There's no UX people here. My gosh, we ought to be ashamed. So the third thing you will do when you go home is take some UX classes or read some UX books or hire a UX person. This is about people. This is about human psychology. It's not about technology. And even the Agile Manifesto says this. Okay, so we start out and, we start proceeding through the base camps. And we get here, we camp out for the night. We get up in the morning and we look up here and say, oh, there's a pretty steep cliff there. And we look over here and say, well, that's not too bad. So we make a decision. We inspect and adapt. And we're going to go to the right. And so we do that. Oh my gosh, here I need to come back down the mountain a ways. That's rework. Just because, there's a big canvas here and I cannot cross it. So it's another, 1, 2, 3, 4, 5 days to get to the top. If I had gone that path on the left, oops, sorry, wrong button. That's the problem of having this down here. There we go. Back up to the base camp. Looking what direction we're going to go. Then taking the wrong way to the top. Because, of course, we should have taken this path to the left because that's only 2 days. Now, taking these paths is very costly. And I mean, what I could do is build a prototype for each of these paths. Or I could go part way up the path and send some scouts up to try to assess, which one is going to be the worst. Scout it and partially climb it before making a decision. Partially climb each one that's a viable alternative. That gives me more data to make a decision. Because if I'm inspecting and adapting based on local knowledge, I'm just guessing. So this is what I'm going to propose. Instead of trunk-based development, where we keep moving forward, at each step, we're going to evaluate alternatives. So it's not trunk-based development anymore. It's branching. I mean, you've all been told, avoid branching. Well, maybe at the low code level, and certainly at the level of a team working on a product backlog item. I mean, if you are really swarming, if you're really doing Scrum, you have 5 people changing the code every 10 seconds. But it doesn't matter because you're all sitting at the same table and all looking at the same screen. Okay, so you don't have a lot of waste. You will not have a lot of rework. The reason is that the team is working as one mind. That's Scrum. It's not Agile. Agile just means, I'm going to give myself the freedom to change. And the method that most people use is this inspect and adapt. So we want innovation. This is the problem that Takeuchi-san and Nanaka-sensei set out to solve. And they did experiments with Canon. Anyone here from Canon? The Canon one-shot was done using this all-at-once approach. Nippon Electric, NEC, Honda, any Honda people here? I guess none of the people who started this right are here. So Takeuchi and Nanaka underscore the need for overlapping parallel streams of work. That's where the term Scrum comes from. Because Could you two help me? Please come up here. It's okay. It's easy. So what Nanaka Sensei noticed is that everyone was doing everything together all the time. A little analysis, a little testing, a little development, and then we swap after 10 seconds. And so all of our work streams overlap. So this is everyone doing everything all the time. So Nanaka Sensei wanted a metaphor for overlapping work. What does it mean for human beings to overlap? What is this? What is this? This is a scrum. That's where the word scrum comes from. I mean, I have this directly from Nanaka Sensei. It's not about sprinting the ball down the field or anything stupid like that. It's about overlapping work, overlapping parallel work, not trunk development. Okay? And so this whole idea, there's a chapter in this 1990 book by DeGrasse and Stahl that talks about how to do this in software. And it's really refreshing. So, find yourself a copy of this or send me some mail. I can send you the PDF from those pages in the book in English. I don't think it's been translated into Japanese. And if so, it's very, very old. And then those other two guys commercialized it in 1995. And Scrum, I mean, Agile comes from Scrum. Scrum does not come from Agile. We had Scrum teams running in 1993. The Agile Manifesto isn't until 2001. Okay? And was largely, from XP, which basically stole ideas from Scrum and then got them all wrong. Sorry, Kyun-san. We've debated this. So what does it feel like to be on a Scrum team like this? Everyone is doing everything all the time. There's no one who's a specialist in blue pieces, a specialist in white pieces. Some people are working on edges and then working on the middle. Scrum is about this idea called swarming. It's like bees in a swarm when they're migrating with the queen at the center. That's Scrum, not sprints, not the daily Scrum, not the product backlog. It's swarming. That's the essence of Scrum that goes back to the Takeuchi and Nanaka paper. It's also called all-at-once development. We're doing all the phases: requirements, analysis, implementation, design, testing, everything. Everyone is doing together at one table all the time. If it doesn't feel like your group is doing a puzzle together, you're not doing Scrum. You find the other parts of Scrum and all the other methods and frameworks. I mean, this is the thing that is unique to Scrum. And it's swarming at the team member, minute by minute, local level. This is very chaotic. And from the outside, it looks like it's total nonsense. It looks totally chaotic. But the team, because they have experience with each other and because they have the shared artifact, they can see what's happening in the code. They don't even have to talk with each other. It's like they have extrasensory perception or something. But it's, they have this shared artifact called the code. That's Scrum. It's like making this puzzle together. I don't need to talk to the other people about where I should put this puzzle piece. I just look at the puzzle. I just look at the code. So again, for seeing the solution that I'm proposing, let's take that notion of Scrum from the team and individual level up to the product level, up to the business level. Because we also have alternatives to explore at the business level. It's not just, well, should this be a for loop or a while loop? And that's the level at which we say we are agile. I mean, this is not what's going to save software engineering. It's the difference between for loops and while loops. It's, should we use this database or this database? You know, should we optimize throughput or should we optimize latency? It's the business questions that are important. I think we all understand individual development. What I want to do is kind of go through a series of paradigms of development. So in individual development, it's, you know, take a feature, do PDIA on it, you go to the next feature, do PDIA on it, and so forth. Maybe, I mean, some great developers may actually do these in different orders. We'll talk more about this later. And do a little early testing or pre-implementation or, you know, reanalyze when they're done. All of these are very, very good. But I don't know how many developers really do them. I think, you know, the 10x developers do things like this. I think most developers will do things like this. It's safe. No, not the framework. And then we can start to move to a team. And if I look at fashion, we have something called mob programming. And what mob programming is I mean, someone might do some planning. We kind of pass the ball around. I'll say something about planning and pass the ball to you. Then you say something and pass the ball to him, who passes it back to me. So it's one person at a time. And there's one navigator who's typing the code in as people tell her what to type. And there's a facilitator who facilitates the process. So I learned this from Woody Zuil in Sweden. And so it's another style of development. I think it's good for team building, maybe in a young Scrum team. But it's a terrible, terrible, inefficient way to build code. And again, there's nothing here that says anything about backtracking or about exploring alternatives. It's all trunk development. Probably more so than if I don't have that facilitator. The facilitator is like leading an orchestra and making sure they're all moving forward. And so it's going to be trunk development. Then we have this terrible, a slide got lost here. I did some edits to the slides right beforehand. So translators, I want to talk about Kanban, which is, I think I inadvertently deleted that slide. Yeah, let me talk about Kanban. So what Kanban is it's limiting work in progress, or at least American Kanban from Anderson, is that the manager will come and split the Scrum team in two and say, we're going to run at most 2 features at a time. Because if there's more, there's too much confusion. And when we integrate the features back, when we integrate the branches back, it will be too complex. So I have parallelism going on. And it's parallelism for the same product. I mean, when I'm done, I will merge these things together. But unlike swarming, where I'm diverging and merging together on about a 10-second cycle, it's more like branching, when I'm going to create a version branch and go off on the branch by dividing up the work. There is no Kanban in Scrum. And I mean, the Scrum Guide says there are no subteams within a Scrum team. It explicitly says this. And Kanban, the original Kanban from Toyota, was invented by Ono-san. And the goal of Kanban is to eliminate Kanban. He said, you know, eliminate as much Kanban as possible. Liker said, it's a sign of something wrong with the organization, not something to be proud of. So it's just, you know, an American consultant who took a fancy Japanese word and catered to managers' need for control of the team and designing tasks. This is not how Scrum works. No Kanban in Scrum. And then in Scrum, how does Scrum work? Well, in Scrum, everyone is working and thinking and modifying the code. And you're thinking, oh my gosh, I mean, how do they synchronize with each other? Well, they're all at the same table. And they've kind of set this up saying, you know, I'm going to work on this, I'm going to work on this. Or maybe we do, I mean, this is kind of like pair programming at the team level, expanded from 2 to 5. And in fact, if I look at this early paper by DeGrasse and Stahl in their chapter about all at once, they say one person can do this. This is called hacking. 2 people can do this. They call it handcuff development, but it's pair programming. And when I do it for a full team, it's Scrum. So this is like putting that puzzle together. Okay? A good Scrum team should feel like putting that puzzle together. Now, this is at one level of granularity. And now what I want to do is scale this. Scale this in what dimension? Scale this in the dimension of evaluating business alternatives and then getting feedback about those alternatives. That's what Agile is about. Feedback between alternatives, not just feedback about, did I do this right? Did I do this wrong? Because there's 100 ways to do things wrong. And if I'm doing inspect and adapt, I'm only evaluating one of them. I want to expand the scope of that. So one way of doing this is building prototypes. And there's a whole spectrum of building prototypes. And I want to give you kind of 2 endpoints of that spectrum. So one is I start by building a minimal viable product. By the way, I hate minimal viable products because they're never minimal, they're hardly ever viable, and they really are not products, right? But then I take that and deploy it in order to get feedback, and then I iterate, make some compromises, deploy again, iterate, compromise, deploy, and eventually end up with a ball of mud that has all the compromises necessary to make everyone happy enough. The other extreme, and of course there are points in between. Oh, first of all, this is kind of wrong because if I have good designers, good UX people, they're going to probably have a very good idea on what the interface looks like by building paper prototypes before I go into a minimal viable product. And then the rest of the product, you know, will have a lot less rework. It becomes a lot less, a lot easier. So, I mean, most efforts on building minimal viable products start wrong. You want to start on a good analysis basis from a UX person. The other thing you can do is the full Monty. Do a complete analysis. So this looks like a product. So do a market analysis, do full product development, and deploy it. Is that a prototype? Is this a prototype? This is a 1987 Toyota van. I owned one. Best car I ever had. And it was the first of its kind. It was the first front-wheel drive Toyota van that Toyota made. They wanted to evaluate front-wheel drives with real market experience. So they built this van. And it was just called the Toyota van. I think in Australia it was called the curbside van. But I mean, it didn't have a real product name. It was just the Toyota van, you know, the thing. And they produced this for several years. Then they stopped building it. They took the knowledge they got from building this, threw everything away, and built the Prius. But the Toyota van, They threw it away. This was not an incremental change. These were fundamental lessons that they learned from that beautiful van I once owned. This is more like Dave Thomas's pattern, where he's throwing something away every third release. This is how Toyota does things. You can't incrementally change a car. I mean, you can, but you kind of have to wait for a model year. Okay? They threw away a whole car. How much does it cost to build an assembly line at Toyota? It's a big number. I don't know what the number is. So, how much code did you throw away today? As much as a car? How do you solve the problem? Well, let's look at lean principles and agile principles. What are some of the agile principles? Okay, small batches. A Scrum principle is decrease variation. Oh, decrease variation. Why? So I can measure. So I can manage it. This is the whole foundation from Deming for the plan, do, inspect, act cycle. I need to reduce variance before I can have something to measure on my cycles. Okay? So what should we do? Increase variance. So I showed you two ends of the spectrum here. What you want to do is build several prototypes to evaluate several points on the market spectrum. Build them not all the way, build them far enough that you can learn something, and then evaluate, this one is not going to be a winner, and throw it away. And now do the next cycle. That's more agile than the silly child's game of inspect and adapt. Right? So let's take Scrum again. We all know Scrum, everyone doing everything at once. And we have one Scrum team to start with, and we want to do a plan, do, inspect, act exercise to implement. Let's say we're going to figure out what database technology to use. So the first thing we do is plan. What alternative database technologies should we evaluate? Well, okay, we do some research, and the two candidates look like MySQL and Oracle. We've done the evaluation. Good due diligence. Plan, now do. We add another Scrum team, and we build them both. Not all the way, about halfway. There are actually tables in books you can look at that tell you how far you need to go in order to get the knowledge you need to make the business decision. At some point, you decide you have enough information, and now you inspect and act. I have two alternatives. Which one of these is not going to make it? These are development branches, right? I should merge them together, right? No. I delete that one. I throw it away. This isn't about branch and merge and branch and merge. This is about branch and discard, branch and discard. This ends up giving you a solution which is much more thoroughly covered the market space. It costs about the same as all that stupid refactoring that you're doing, combined with the fact that 60% of the code that you deliver is the wrong code. What percentage of your code is never used or rarely used? You don't know? You don't even know? I mean, you should instrument your code. I mean, studies have shown it's about 60% worldwide of software hardly ever gets executed because companies deliver the wrong thing. And then end users end up never using it. There's another reason that it's used. I mean, How many of you have really increased your productivity using Scrum? You know not to answer these questions now. Right? Taiichi Ono said, overproduction is the #1 cause of Muda. This is not about productivity. This is about value. And I get value by assessing alternatives and making hard decisions and throwing stuff away. See, it's hard work to get that knowledge. How many of you have worked on a project, a software project or something else? Maybe you're remodeling your house and you spend a lot of money. And you know the roof still leaks. Okay, so you spend some more money at patching it up and it still leaks. So at some point you could just tear off the whole roof and replace it with a new roof. But what human beings do is they keep patching the holes. Why? I've spent so much money on this, I can't afford to throw it away, so I need to spend more money. Wait a minute. I've spent money on this, and so I need to spend more money instead of throwing it away. This is called the sunk cost fallacy in economics. And it's a psychological barrier to killing something that isn't working. I mean, we're invested in that code. It's my code, and I'm a smart guy or gal. And if I'm throwing that away, I'm admitting I'm a failure. So I'm going to put more money in it to show that I'm a good person. No, throw it away. So again, this isn't just software. This is a basic tenet in economics called the sunk cost fallacy. It's a basic tenet in psychology when Freud said you're going to be hoarding your feces. It's a basic tenet in management because they don't like to manage the complexity of alternatives. But it produces a terrible product. Okay, so yeah, how much code have you thrown away today? This isn't just about, the 10 lines of refactoring. What 10,000 lines of code have you thrown away today? See how this works? That's Scrum. So a more realistic example, how am I on time? Huh? Okay. So let's say I'm building a product. Am I using Mac or Linux or Windows? Am I using Oracle or Sybase? What programming language am I using? What I'm going to do is first develop some questions, evaluation questions, like how would I know the right answer if I saw it? So what's important for the operating system is, does this fit the market? What's important for the database is, are there compatibility issues? What's important for the language is, are there cost issues? And I build them all. Not all the way, just far enough that I can say, okay, Linux ain't going to work. Windows ain't going to work. Stop development. Okay? And we're going to terminate those branches and just throw it away. So we've thrown away Sybase, we've thrown away Java, thank goodness, and thrown away Linux and Windows. Now, what do we have left? We have, well, if it's Mac, is it Mac OS or iOS? Oh, here we've added a new one. We have learned something. So we added MySQL. So C++ or Ruby. And again, I develop questions that I will use to assess what the right alternative will be. And I do development just far enough to be able to say, well, I know that I can eliminate some of these. I can eliminate Ruby, I can eliminate Oracle, I can eliminate iOS. I have another layer. I develop the questions as before. Develop them far enough that I know what to throw away. Throw away the ones I'm going to throw away, and I have product. I'm done. 8 minutes? All right. Every cycle, I'm decreasing the alternatives and increasing the options within each alternative. How do I do this? Increase work in progress. To hell with the work in progress limits. So what I'm doing is running a series of experiments. I'm a scientist here. I mean, you say, oh, I do testing all the time. No, testing is not experimentation. Testing evaluates whether the implementation meets my assumptions. Experiments test the validity of assumptions. When you're doing agile, you're assuming your assumptions are right. And you're testing against your assumptions. I mean, what, are we stupid? I mean, there's no reason our assumptions should be right. So I'm doing real experiments. We're scientists now on each of these iterations. Now, who uses it? Toyota uses this in automobile design. Google uses this in all new software product development, particularly for user interfaces. You will find a chapter on it in a Scrum book that describes what I've just told you about. And again, this is a very mature practice. It's been around a long time. It's just that people don't talk about it at this conference. Now, there are some footnotes to this. What are the repercussions? Avoid trunk-based development. It's a crutch for teams that don't have teamwork. Use set-based design. And this takes discipline and good teamwork across teams. Replace serial iteration with parallel assessment. Oh my gosh, this is a Scrum conference. We have a Scrum value called focus, which means I focus on one thing at a time. My gosh, are they going to take away my Scrum trainer certification? Don't confuse Scrum with the Scrum Alliance. You are to think. Now, I can serialize this and have one team do one variant and then do another variant and do another one. But that has some psychological traps because your opinion of the world is changed by what you did in that first iteration. So I really think it is important to do these in parallel, not just to have one team do several alternatives in serial. Now, within each team, yes, still do Scrum. Use swarming and continuous integration within teams, and use set-based design across teams. Stop treating code as an asset. Code comes from typing, not from thinking. You can type a whole system in a day. Hoarding code is the sunk cost paradox in disguise. And it's this, hoarding our feces in Decide. The value asset is knowledge, exploration, dialogue, planning, learning from the past. That's the value. Armed with these things, building product is a no-brainer. These things will not necessarily come from building product, but building product can come from these. So the output of a sprint is learning. And like I said, I think that what Nonaka-sensei is going to be remembered for is his Seiki model of organizational learning, much more than he will be remembered for Scrum. This is about learning. Build one to throw away, like Fred Brooks says in his book, The Mythical Man Month. Set-based design and walking the branching tree are throwing code away. Now, this is also true for conflicts that arise from continuous integration. But usually we don't throw those away. We try to merge, and that's the problem. Software should be soft. That's why it's called software. And the cost of typing is low. So plan on throwing away 70% of your code. I mean, right now, what are you doing with that code? You're shipping it to your end users and they never use it. We know this. 60% of code is never used. Throw it away. And in refactoring, you're changing another 20%. There's another 20% you're throwing away. Change means delete and add. So this isn't more costly than what you are doing already. It's just a lot smarter. And it's going to cause you to better deliver something that meets the end user need and solves the problem because you understand the problem better, and it drastically reduces waste. Probably by, I don't know, a half an order of magnitude. The Google people have some numbers, but I mean, every company is different. All right, kill reuse. How many of you are using reusable frameworks? I mean, this is very costly and they never perfectly fit your problem. And so you have to kind of, cheat to make them fit. And then when a new release of the framework comes out, oh my gosh, the conversion cost is a nightmare. Stop it. Toyota doesn't going around reusing things that are manufactured, overseas. Everything that Toyota uses is made within 2 miles of the assembly point out here in Toyota City. It's all under one roof. So, yeah, I mean, the small stuff, I don't know if they build their own nuts and bolts. But so for things like simple libraries or compilers, commodity software, by all means, use that. It's not reuse, it's use. But all other tools, be like a Japanese temple builder. First thing a Japanese temple builder does is build their own tools. You want the tool to fit the job. So last slide, conclusion. Development paradigms cover a spectrum that goes from solo projects all the way up to set-based design and beyond. Agile proposed and sustained bad ideas that result in local optimization, like climbing Fujisan, and the momentum of instant gratification. The psychological forces here are very, very powerful. Many software engineering practices like reuse, trunk development, and code as asset reinforce this myth. So it's time to move beyond Agile into better proven approaches. Start by just doing swarming in Scrum. And at least you can say you're doing real Scrum and not just Agile. Set-based design and others are closer to the ideal. And I'll end with one question for you. And if there's time, you can have questions for me. What does an Agile coach do? Thank you very much.
Thank you, Coplien. Today, we can have 10 minutes to have the question and answer.
Okay.
Okay.
Thank you very much.
10分だけ。はい。じゃあ、ちょっと10分延長になってしまいますが、質問ある方、このルームの方は英語でお願いします。他のルームの方は日本語で大丈夫です。If you have any question, you can speak in English, this room. 他のルームから声出していただいても大丈夫ですよ。ディスコードは読まないので。
Yeah, I know it's a tough topic and a tough talk. So I'm curious, take a poll. Are they? And I'd like to take a quick poll. Are they lost? Do they think I'm crazy? Or are they scared to death? One of those three. How many are lost? Yeah. Yeah, I mean, this is out of anything you've been told before, right? How many think I'm crazy?
コープさんおかしいんちゃう
Buy
か
you
って人
beers afterwards. And I mean, how many are a little scared? Yeah. You can't be both. Yeah, I mean, this is a very, very, very deep talk. And to me, this is what a keynote should be. Now, a keynote at a conference is supposed to set the tone for the rest of the conference. So be thinking about my talk when you go to every other talk. Are they making incremental, inspect, and adapt more incremental? Is this making this worse? Are they exploring alternatives? Are they focused on value? Or are they just focused on tools? Are they doing swarming? Do they understand that the core of Scrum is swarming? So, I mean, I'm very concerned about the Scrum and Agile communities. They've really kind of, I think, lost the main thread. And, you know, as one of the very early people in Scrum, I want to try to pull the community back as far as I can. So yeah, I mean, this is very deep stuff, and will probably take some time to soak in. And there's a video of it, so you can look at the video, and maybe you will hear something different every time you look at this. Kyon, thank you very much. It's time to end now.
はい、キョンさんが質問したいそうです。
セットベースド開発のアイディアは非常に素晴らしいと思いました。ズームで OK。セットベースド開発はそのトヨタのような、非常に大規模な予算を持っている会社しかできないというのが今まででした。ですが、今日のお話は、我々のような、非常に低予算な、ソフトウェア開発スタイルでもセットベースド開発をやっていってはという一つの提案だったと理解しています。ズームの方大丈夫
Yeah, I don't think it's more costly. And yeah, I mean, to do things in parallel, you maybe need several teams. And in that regard, it may be more suitable to a development which has several teams than just three developers on one team. And so, yeah, it may be that a smaller team is going to be putting a lot more effort into prototyping. And so this is just one tool in your toolkit, and prototyping is another tool in your toolkit.
ありがとうございます。そういう意味だと、スクラムっていうのは、最大10人とか9人を対象にしていますけども、今日のお話だと、もっと小さいメンバー数で、パラレルな開発をしていこうという提案なんですかね。
Okay, so parallel translation is not working because I'm getting, so maybe let him finish and then you can translate, because I cannot hear both of them at once. So can you please repeat the translation if you remember it? Hello.
Okay.
Okay, yeah. どうぞ。
はい。スクラムは、非常にこう、8人から10人、最大8人から10人までのチームを想定していますけども、先ほどのご提案っていうのは、むしろ2、3人のような小さいチームでパラレルに開発するっていう前提があるということでしょうか。
So first of all, by the Scrum Guide, 8 people is not a Scrum team. It can't be. And what we have found by experience is a great Scrum team is 3 developers. So, I mean, if you have a 10-person Scrum team, you can do set-based design with 3 alternatives, split it into 3 teams. No, 10 people is not a team, it's a gang. You cannot get teamwork out of 10 people. There's study after study after study, not just in software. But the output of a team will increase up to about 5 people, and then as you add more people, it falls off. And we found 3 is kind of the sweet spot for complex development.
ありがとうございます。で、それを実践するときの、課題に、セットベースの開発ですと、やっていることって、非常にこう大きいリュード、事業アイディアが大きいリュードでコンカレントにやってるんですけども、先ほどの話だと非常に小さいリュードでコンカレントに、開発することになるので、そこのマネジメント手法っていうのは現在開発されていないという認識です。なので、大きい単位ですとマクロにしか検査しないので、マネジメントがしやすいですけども、小さい単位でのコンカレントデベロップメントっていうのはマネジメント手法が確立されてないので、非常にこう無駄に対する感度っていうのが、今まで以上に求められるんですけど、なんかそこは小さい流度でコンカレントデベロップメントに対するこうマネジメントやインスペクトの仕方っていうところでなんか考えられていることはあるんでしょうか。通訳を困らせてしまってすみません。日本語チャンネルで流れてる。ちょっと通訳は
Well, we have this wonderful phrase called self-managing teams, which you might have heard of. So at the level of swarming, and you're right, there are these alternating layers. And I haven't quite got all of this figured out because I think it varies from product to product. But at the very lowest level, we have swarming. And I mean, if I have more than one person, there's more than one mental consciousness. But the goal of swarming is to unite those into one consciousness. That is, so consciousness is a sense of presence. Okay, I exist, I am here. And I want the team to have one sense of being here. And so there isn't need for a follow-up process to clean things up or to merge things. At the level of swarming, I mean, people can be interleaving code and interleaving things. It's just like making a puzzle. I don't have any cleanup process. I don't have any method. Kind of at the next level, I run into a lot of evil things like Kanban, you know, where I'm taking a piece of work and splitting it in 2. And it's kind of like, you know, Solomon, when 2 women were saying, this is my baby. He says, oh, no problem. Cut the baby in half. And then you find out who the real mother is, right? And so there are some uncomfortable things. And unfortunately, what most agile coaches are doing is talking about this bullshit in the middle. So stuff like Kanban and stuff like branching and stuff like refactoring, all of those are these things in the middle that entail rework and avoid this issue of doing swarming. And then what I'm talking about is the next level, which is between teams, where teams are taking more or less a whole product, or in Scrum, a whole product increment. And I'm going to develop this product increment, and I'm going to develop this product increment, say, using another technology, or programming language, or database. And now I will compare them. And one of them is better than the other. Throw this one away. Move on.
なるほど。むしろ、あれですね、今の話はコンカレントデベロップメント、セットベースデベロップメントが良いっていうのもありますけども、それ以上に今のお話から私はアレクザンダーのジェネレーティブ性を非常に感じました。ソフトウェア開発におけるジェネレーティブを取り戻すという運動だと思うと、非常に納得がいきました。ありがとうございます。
Oh, yes! It's all the same thing. But these are not patterns, people. So I did not want to go, yes, that's exactly what it is. It's exactly what it is. He's talking about emergence. And in Agile, we usually talk about emergence as being a bad thing, like emergent requirements or emergent bugs. You can have emergent synergy, and that's what swarming is trying to do. It's not, you get more than the sum of the parts. And this is why, Scrum teams are like magic, and it's hard to understand how they're able to do what they do when you see a team that's really doing swarming. Time box. I want to warmly thank all of you. If we happen to meet over beers, I'm happy to discuss this with anyone. It's what I'm passionate about right now. And I mean, I'm concerned about the survival of Scrum and Agile. We're teaching about, one half to 1/10 the number of people that we were, 15 years ago. And it's because Agile has gotten a bad name. Agile coaches have gotten a bad name. And you know what? They deserve it, because we're doing all these things wrong. And it all goes back to some very early misunderstandings. If we're Agile, we can fix it and change. This is not a Kaizen. This is a Kaikaku. This is a big deal if you want to go home and fix this. So I challenge you to do it. I mean, I think the future of Scrum depends on it. Thank you much all.